Okay, this is our presentation on classifying metals. What is metal? Think about that a minute. Yes, Metallica is a form of metal, but not what we're talking about today. Metal is any of several chemical elements that are usually shiny solids that conduct heat or electricity and can be formed into sheets, etc. Several is a little a little deceiving. There's a lot more than several metals. Where do we use metal? Think about that. Well, quite possibly in every industry on the planet. I was challenged once, what about basket weaving? Well, most likely the tools that they use to cut down the plant materials to make the baskets are metal, and there's probably some other tools that they use which are metal. So it would be really hard to think of an industry that metal is not used. Here is the aircraft or transportation industry. And this is aircraft aluminum, and aircraft aluminum is a mixture of aluminum and copper and a few other elements, which we'll discuss as we go on. The reason for aircraft aluminum is it's very strong and lightweight. Also in the transportation or the automobile industry, every car, I shouldn't say every car because I have seen some novelty wooden cars, but every car on the road and that is manufactured has a lot of metal in it. Most of them, the body and the chassis are made out of steel. There are some high-speed racing cars or custom cars that have titanium bodies and maybe carbon fiber bodies, which is not a metal, but most of the structure of cars is made out of metal, usually steel. Same with bridges and the civil engineering area. Bridges and construction are use a lot of steel. Steel, I like to say, made America, and I'm not the first one to say that. With our steel industry, we are able to, life would be completely different if we didn't have steel to make structures such as bridges. Underneath the floor I'm standing on is concrete, and inside that concrete is steel reinforcement known as rebar. The window frames around the windows here at school have metal and used in all sorts of areas of construction, not limited or not excluding nails and screws are made out of metal. On the left is precious metals, which is a jeweler. There are precious metals such as gold, silver, pewter, not pewter, but platinum, and they hold, really the most expensive part usually is the stone. If it's a diamond ring or a ruby necklace, the metal, we trust that metal to hold that stone in place, even though metals such as gold are very, very valuable and range around $1,500 an ounce for gold. On the right is a candy factory, and it's kind of tough to see, but the food industry relies heavily on stainless steel. That's a type of steel that can be and is non-corrosive and is easily cleaned and sanitized for making food. You may even have pots and pans in your kitchen or silverware that are stainless steel. If there isn't metal in it, metal is used to make it. These tools here are 6,000 years old. They even have found tools, I believe, up to 13 or 15,000 years old that use copper. So these tools are metal made from copper. Copper is an element that exists in its pure form on the planet Earth, and I'm sure other planets as well. And it is melts at somewhat of a low temperature. So back 6,000 years ago, I'm sure our early ancestors found remnants of copper in the bottom of their fire pits after rocks containing copper had melted out, and they realized its usability. Here is titanium and stainless steel to construct a replacement hip joint. This long part of the replacement hip gets literally hammered into the femur, and this being titanium is hypoallergenic, which means it does not react to the body. The stainless steel is non-corrosive and very doesn't wear easily, so it is actually part of the joint. So this is a mixture of two different types of metal to replace hips. How many different types of metal exist? Well, here's the periodic table, and almost all of these are metals, and a few of them are non-metals, up here in the green, and some poor metals, and there's another term for that. But we have metals that we are commonly used: titanium, iron, cobalt, nickel, copper, zinc. All of these are very commonly used in creating products today. So if you count those up, there's 88, but in reality, there's many, many more, because we can take metals such as aluminum and copper and mix them together and come up with an alloy. And alloys are more than one metal element mixed together, and that changes the properties. So essentially they become a separate metal of their own. So when we mix today, we are still solving problems and figuring out ways to mix different metals from the periodic table to come up with new metals. And when we figure it out and do the calculation, there are thousands and thousands of metals. What jobs deal with metal? Can you name any? I'm sure you can. Well, easily to think of welders. Welders are very good occupation, requires a lot of hard work, steady hands, and lots of concentration. Some good training and getting some certification goes along with becoming a welder. Welding happens underwater, welding happens on skyscrapers, welding happens on our oil and gas lines, welding happens on automobiles, and many, many, many other products. HVAC, which stands for heating, ventilation, and air conditioning, is a very common form of metalworking. In your house or your apartment or your place of residence, there is metal ductwork that pushes air, or I should say allows air to travel through to different rooms and different spaces. So your furnace or your air conditioner is pushing that air through ductwork, and that is a skilled trade all of its own. You could easily become a professional heating, ventilation, and air conditioning installer and do that as a lifelong career. Manufacturing, without question, uses lots of metal, all the way from the automobiles to the machines that do packaging or bottles to cutting out parts. This here is either a laser or a plasma torch, and here in our shop we have a plasma torch that will cut through metal, very similar to the way this one does. Machinists are metal workers. In fact, when you think of, or you look around your room or the space you are right now and look at nearly any plastic object, I say nearly, and my guess would be over 99% of plastic objects are the result of a machinist that makes molds. And the mold is made out of steel usually, and with a steel mold, you can get plus or minus in the neighborhood of 1 million plastic parts from that mold. If we made the mold a little lighter and easier to machine out of aluminum, an aluminum mold could get 100,000 plus or minus plastic parts. So the benefit from making a mold to produce plastic parts is once that mold is made, it is very rapid and very cost effective to inject plastic and make plastic parts because of the machinist or the tool maker who makes the metal mold. Foundry is where metal is melted and poured into molds. Many things are done this way. Engine blocks, fire hydrants are a good example. If you have seen a fire hydrant, the surface looks a little bit rough and it's painted. So that is going to be a cast iron fire hydrant, and it's painted because it will rust if it's not painted. And then the parts that have threads for the caps and the screw fittings are machined after the fire hydrant, or for that matter, engine block, are poured. There are many objects. Lots of the tools we have in our shop, including anvils and our milling machine bases, are poured from liquid steel in a foundry. Side note, that steel that is being poured there is close to 3,000 degrees Fahrenheit. Yet another occupation that uses metal is a surgeon. Surgeons will tell you that the experience you gain in a metal shop directly applies to the skills that they use performing surgery. They have to drill holes and use hammers and insert screws and read drawings such as this. In this case, a drawing may be an MRI or an X-ray, but having the ability to understand what that three-dimensional space is like and knowing how to repair that. Yes, a lot of education goes into being a surgeon, but you would certainly benefit by having experience in a metal shop if you are bound to be a surgeon someday. Here we're starting to talk about the different types of metal specifically, and this is the periodic element iron, and Fe stands for ferrous. Ferrous means iron. Ferrous, not this guy. Metals which contain iron are ferrous. Ferrous is I use the word backbone, but the ingredient in many different types of metals. Metal or iron out of the ground is useful, but not nearly as useful as once it is mixed with other elements. Not this guy. Ferrous. Cast iron has a white, grainy appearance when broken and can be very hard. White cast iron has a white appearance when broken. Kind of did those in reverse order. When white cast iron is broken, it has a white grainy appearance, and gray has a gray grainy appearance. White cast iron can be very hard and is used for making parts in machines such as pumps or engines that have a lot of wear, meaning there's a lot of contact with other surfaces and they might wear out quickly. Gray cast iron is easily cast. It's very fluid. As I mentioned earlier, fire hydrants are gray iron or gray cast iron. Wrought iron might be the closest iron that we use on a common basis that is most like the iron from the earth that we extract. It's very inexpensive. It's very workable, and you see it often in things like decorative gating and whatnot. Steel built America. Steel is not only iron, but a mixture of other elements. The steelmaking process is quite complicated, and it took quite a long time for us to figure out how to do it in a mass production method. In the past, the Japanese samurai sword makers figured this out thousands of years ago, but it's a slow, time-consuming process. All steel is ferrous. All steel contains iron. This guy here, though fictional, has a sword. He is from Lord of the Rings. You may know him, Frodo, and he carries the sword Sting. Well, the legend or the story goes that the elves were master steel workers, and they were able to produce the steel that was of extremely high quality. In the movie, this steel glows blue when orcs come around. We have not figured out how to make steel glow blue when orcs come around in modern day. This, yet a very violent movie, has a story of Hattori Hanzo, who is the master sword craftsman. And Uma Thurman's character in this movie spends many, many months proving herself to Hattori Hanzo that she deserves him to make her one of his awesome swords for revenge. Hundreds of different types of steel are produced. Hundreds. We will look at a few of them. A key part here is steel is between 0.05 and 2% carbon. The trick to that is in a Bessemer furnace or other methods, we take the iron and burn out all of the copper, just get exactly pure iron, and then add exactly the amount of carbon that we want. So low carbon steel, known as mild steel, which we will use in abundance in our shop, you may be familiar with that sound, contain from 0.1 to 0.3% mild steel or low carbon steel, and is produced in a Bessemer or open hearth electric process. These steels work easily, can be welded, and come in all different shapes. We get quite a bit of this through our shop, mostly because it's easy to work. and inexpensive. Medium carbon steel you'd find in tools such as pliers or hammers that are very a little more expensive than low carbon steel, but contain 0.3 to 0.6% carbon. They're a little tougher. They will withstand the abuse that tools take more than low carbon steel. And the ultimate here is high carbon steel. High carbon steel can be very expensive, and it has from 0.6 to 2% carbon. There are many levels of high carbon steel used for many, many tools, but the point when you get the high carbon steel, they become quite frequently steels that will cut other steels. This on the right is a die, which is used to cut threads into rod. So this will cut steel with steel. A visual comparison, small amount of carbon overall, but just a little difference makes a big difference. High carbon steel is the bomb. Here are the definitions of hot rolled steel and cold rolled steel. Essentially, hot rolled steel is steel that is shaped while it is hot, almost to the point of melting. It is very, very warm, and those molecules inside of the steel are bouncing around when it is rolled or shaped through dies. And what happens then, as it cools, those molecules kind of bounce around and come to rest in a position, so it's a little more softer. Cold rolled gets pushed through in these machines that are extremely strong and powerful because it's not hot, and it work hardens metal or the steel. If you've ever taken a piece of steel and bent it and then tried to bend it back, it's actually harder to bend it back than it was to bend it in the first place. That's called work hardening. Same with blacksmiths who hammer on metal and jewelers who work with metal. The metal gets hard and more difficult to work the more it is worked. Cold rolling is the process. High-speed steel is used for drill bits and cutting tools. And frequently, if we could magnify in on this, it would say HSS, high-speed steel. It is composed of iron and elements that make it resistant and retain strength at high temperatures. When you cut metal with metal, and that would be the same case for drilling, you are literally cutting metal with that edge, the metal gets very hot. Well, we need our tools to stay sharp at those high temperatures when it's getting hot. We certainly like to use fluids, cutting fluids or oils to There we go. High-speed steels. Spring steels. The process of making spring steel is really interesting. It is a heat treating process. So once different springs are made differently, they may be heated up for a certain amount of time, we'll just say an hour, and then dipped in an oil, and then heated up again and dipped in water. Or every spring manufacturer has their own secrets and how to get the springs that will return to their springiness every time. So millions of times a spring will not lose its springiness. However, if that spring is heated up to a high temperature and then allowed to cool, all the springiness is gone. That brings up a really interesting point about the whole process of manufacturing steel, that there are many ingredients that are mixed all on the periodic table, and they get mixed with iron to create a steel that it suits the needs of the application it is to be used for. So, for instance, stainless steel is very corrosion resistant, and it has a high percentage of chromium. These are high resistant to acids, to even simply water and rusting, which is called oxidation. Stainless steels can be very expensive. If you buy 2 screws in the hardware store, one that is not stainless steel and zinc coated might cost 50 cents, and its equivalent might cost $1.50 or $2 in stainless steel. However, it is stainless steel all the way through. It will never rust, even if the surface coating is worn off. These are codes for steel. The American Iron and Steel Institute and Society of Automotive Engineers. This classifies the steel and how much carbon is in it, and it's a reason why we in the United States or America have very good quality products, because we hold ourselves to a high standard and we know what steel is being used, and in certain applications it cannot be a low quality steel for that application. Copper has been used for, as I said earlier, thousands of years. The Bronze Age is relatively newer. Bronze is the mixture of copper and tin. Brass is the mixture of copper and zinc. So copper, tin, and zinc are all on the periodic table, and by mixing them together in the right proportions, you come up with bronze and brass. The sculptures you see around that are big, lifelike sculptures are made of bronze. In Loveland, Colorado, we have multiple bronze casting foundries. Sometimes these castings are made for many other states around the country and even have been shipped overseas because of our expertise in casting bronze. Copper plus tin equals bronze. Copper plus zinc equals brass. Zinc and tin by themselves, zinc is very corrosive resistant. In fact, on most of these shiny screws that you will see, or also you could think of galvanized fence posts or chain link fence, that has a zinc coating on the outside, which prevents it from rusting. And as we mentioned, mixed with copper makes brass. Tin is a soft, shiny metal used in food containers, and mixed with copper makes bronze. Pewter, I wish I could hand you a piece of pewter right now because it simply feels soft. Like it's not soft to the point that you can squeeze it like a marshmallow, but it has kind of a soft sensation to the touch. And small sculptures and kitchen utensils. The nice thing about pewter, it has a very low melting point, so it's been around a long time where people are able to make castings with pewter because of its low temperature. Titanium is an incredibly durable, strong, and fantastic for its weight ratio. It is Many things are made of titanium, such as eyeglasses and racing components for cars, airplanes, bicycles, and anything that might have metal components on it. It is as strong as steel and as light as aluminum. An interesting story about titanium is that the SR-71 Blackbird is made from titanium, and it was designed and built to spy on Russia back in the Cold War. Well, most of the world's titanium exists in Russia, so we were getting our titanium from Russia and building SR-71 Blackbirds to spy on them. Aluminum, to us, seems like, is it worth it to throw it away, or do I walk an extra 3 steps to the recycle bin? Well, aluminum has not always been that way. It is one of the most abundant metals on the planet, and when it's mixed with things like copper, silicon, and manganese, it becomes very, very strong, such as the aircraft steel and structural steel we've talked about. Not all that long ago, aluminum was very hard to extract from the earth. So back when they built the Washington Monument, they wanted to cap it with the most valuable metal on the planet at that time. And at that time, it was aluminum. So to this day, the top of the Washington Monument is capped with aluminum, and I'm sure that that value has dropped dramatically. It all goes back to the company Alcoa, Aluminum Company of America, that figured out how to take essentially dirt and extract the aluminum from the earth, and at a cheap cost. Before then, it was very valuable. Here are 2 interesting ones, tungsten and tungsten carbide. Tungsten is used to mixed with steel to make tools very hard. In fact, the hardest man-made material. Tungsten is an element. Tungsten carbide is an alloy, a mixture of more than just tungsten. And this is one of the hardest materials, the hardest man-made material, almost as hard as diamonds. Tungsten itself, and tungsten carbide is used on tools, and the tips of these saw blades and this little cutter can be tungsten, and they withstand lots and lots of heat and abuse, and can cut through things such as metal. Tungsten, a very common use for tungsten, which we're kind of seeing less and less of these days, is the light bulb. The glowing element in this light bulb is a thin wire of tungsten, and what happens is we pass electrical current through both sides of that electrical wire, and it heats up so hot that it glows. It's in a vacuum, hence the glass bulb, and because of that metal being so hot and glowing, that produces light, and that is how we, until recently, was one of the main methods of lighting homes, but we have come up with other things such as compact fluorescent light bulbs and LEDs. However, this little piece of metal in there is tungsten, and it has a very, very high melting point, hence why that was used in light bulbs. Here are a bunch more elements that are used in steel to make steel better or more useful for its purpose. I will let you peruse that, and you can pause on this slide if you need. At a later point, we will talk about heat treating of metals. And that concludes this episode of Classifying Metals.